This lesson is about inscribed angles. The objectives are to find the measure of an inscribed angle and to find the measure of angles formed by a tangent and a chord. So what is an inscribed angle? That's our first definition. An angle whose vertex is on the circle and whose sides are chords of the circle is called an inscribed angle. So let's draw a picture over in the margin. That may help. Draw a circle. And then we have point A on the circle. That's going to be the vertex that's on the circle. And then draw two sides that are chords. So let's draw a chord AB and chord AC. And that has formed the inscribed angle. Angle BAC is an inscribed angle. The next definition is an arc with endpoints on the sides of an inscribed angle, and its other endpoints on the interior of the angle is called an intercepted arc. So let me change colors so we can outline that. So here in this diagram, this arc BC is an intercepted arc because the inscribed angle intercepts it. So the next, our first theorem in this lesson is about inscribed angles. It says the measure of an inscribed angle is going to be half of the measure of its intercepted arc. So here in this diagram, we have angle, this one is labeled a little differently than we did in ours. This one is angle ABC, and they called it angle B. So angle B, the measure of this angle, is going to be half of the measure of its intercepted arc, which is arc AC. So now we have three corollaries to this theorem. Remember, corollary is a theorem that can be easily proven from the theorem that it comes from. So the first corollary says that two inscribed angles that intercept the same arc are going to be congruent. So here in this diagram, we have angle A, and angle A's intercepted arc, angle A, the measure of angle A is half of its intercepted arc. And the measure of angle B is half of its intercepted arc. Well, they're both intercepting the same arc, so they have to be congruent. So in here, angle A has got to be congruent to angle B. In corollary 2, an angle that's inscribed in a semicircle, so it's half a circle, has to be a right angle. Why is that? Because a semicircle, if you look at the intercepted arc is a semicircle. There's 180 degrees in a semicircle because it's half of a circle. So it's intercepted, that angle of the intercepted arc is half of the intercepted arc. And so here, measure of angle C has got to be 90 degrees because it's half of 180. So you've always got a right triangle. You remember that in some of the problems it's going to use that right triangle that's formed. The last corollary, corollary 3, says that the opposite angles of a quadrilateral that's inscribed in a circle have to be supplementary. So in this diagram, we're talking about opposite angles in the quadrilateral. A and C are opposite angles in this quadrilateral. So the measure of angle C, A plus the measure of angle C has got to be 180. And the other two opposite angles, angle B and D, measure angle D, those also are supplementary, so they have to add together to be 180. The last theorem in this lesson says that the measure of an angle formed by a tangent and a chord is going to be half of the measure of the intercepted arc. So let's look in this diagram here. We have the measure of the angle formed by a tangent, where tangent's only going to touch a circle in one point, a tangent and a chord is going to be half of this intercepted arc. So there's the intercepted arc. It's the same over, if you look at it, go in the other diagram here, we have a tangent and a chord. Only this time the intercepted arc is going the other direction, but it's still going to be half the measure of that arc, BDC. So let's look at some problems using these theorems. In problem 1, we're using the inscribed angle theorem, and it's asking what are the values of A and B. So A is going to be, A is part of this arc, that intercepted arc of this angle. That's 52 degrees. So the measure of the angle is half the measure of the arc. So this 52-degree angle is going to be half of the arc, which is A plus 56. So multiply both sides by 2 to get rid of the fraction on the right side, and you're going to get 104 is equal to A plus 56. Subtract the 56 from both sides, and you're going to get that A is equal to 48. Now for the B part, we look at angle B. Angle B is half of its intercepted arc, and its intercepted arc is just that 56-degree arc. So B is just half of 56. So B is equal to 28 degrees. Problem 2, it asks what is the measure of each numbered angle. So in part A, the number angle is 1, and here we have an angle that's inscribed in a semicircle. The intercepted arc is a semicircle, so that means that the measure of angle 1 has to be 90 degrees. It has to be a right angle, because angle 1 is inscribed in a semicircle. In part B, measure of angle 2 has to equal 43 degrees because of the theorem that says, we'll say because inscribed angles that intercept the same angle that intercept the same arc. Sorry, are congruent. Inscribed angles that intercept the same arc are congruent. Last problem is using an arc measurement. In the diagram, it says that AC is a tangent to the circle at point B. If the measure of BED, so BED arc is 214. Okay, this arc over here is 214. Then what is the measure of angle DBC? So it wants the measure of this angle over on the other side. So what you have to use is the fact that the whole circle has 360 degrees. So in order to get this intercepted arc, the arc that angle DBC is intercepting, you're going to have to subtract 214 from 360, and you're going to get 146. So the measure of this arc is 146, and the measure of angle DBC, so the measure of angle DBC is half of arc BD that you just found to be 146. So half of 146 is 73 degrees.